It has been 2 years since NASA's James Webb telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in space. It captured these images.
This is the first time we get to orbit Mercury.
When we imagine life on other planets, we have to imagine that the environment on those planets will determine what the creature may look like.
Close to the sun, a tiny planet hides big secrets. Mercury, small and hot, fooled us for years. But now, space robots have uncovered weird surprises. They claim to have found diamonds on the hottest planet. And that's just the start. Mercury's insides are all wrong. Too big, too strange. Why is it so different from other planets? And what else is Mercury hiding? Exploring the terrain. Mercury, the smallest planet in our solar system, has been a subject of fascination for astronomers and space enthusiasts alike. Its mysterious landscape, hidden from view for centuries, began to reveal its secrets only when space exploration advanced significantly. The journey to uncover Mercury's enigmatic terrain started with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe in 2004. Mariner 10, the first spacecraft to visit Mercury, gave us our first close-up glimpse of this elusive world. During its flybys, it captured images that showed a landscape riddled with craters and strange ridges, much like our moon. This mission revealed that Mercury had a rough and heavily cratered exterior, along with a surprisingly strong magnetic field and a larger core than expected. These discoveries challenged what scientists had previously assumed about Mercury's composition. The Messenger, aka Mercury's surface, space environment, geochemistry, and ranging mission, launched 31 years after Mariner 10, took our understanding of Mercury to new heights. Unlike its predecessor, Messenger was designed to enter orbit around Mercury, allowing for a more comprehensive study of the planet. During its mission, Messenger took an impressive 200,000 photographs, revealing areas of Mercury never seen before. One of the most intriguing findings from Messenger was the discovery of unusually high levels of calcium and magnesium on Mercury's darker side. This raised questions about the processes that could lead to such concentrations. Additionally, the mission found that Mercury's magnetic field was unusually strong in the northern areas, which was unexpected compared to other planets. These discoveries led scientists to realize that Mercury's internal structure and formation process were quite different from what they had initially thought. On most planets, like Earth, magnetic fields are generated by the movement of liquid iron in the core. However, Mercury's unique internal structure results in different magnetic behavior. But what makes Mercury's terrain truly stand out? It's not just the craters and ridges, but also the extreme conditions on its surface. During the day, temperatures on Mercury can reach a scorching 430 degrees Celsius or 806 degrees Fahrenheit, hot enough to melt lead. At night, they plummet to a frigid minus 180 degrees Celsius or minus 292 degrees Fahrenheit. This extreme temperature swing is due to Mercury's thin exosphere, which does little to regulate temperature or retain heat. Despite these harsh conditions, recent studies have uncovered some surprising features on Mercury's surface. In 2012, Messenger data revealed evidence of volcanic activity on Mercury, including pyroclastic deposits from explosive volcanism. This discovery challenged the long-held belief that Mercury was geologically dead. Even more intriguingly, in 2020, scientists announced the discovery of water ice in some of Mercury's polar craters. These permanently shadowed regions are cold enough to preserve water ice, even on a planet so close to the sun. This finding has sparked new questions about the potential for simple forms of life on Mercury. Could there be extremophiles, similar to those found in harsh environments on Earth, living in these icy refuges? The most recent mission to Mercury, Bepi Colombo, launched in 2018 as a joint effort between the European Space Agency and the Japan Aerospace Exploration Agency, is set to arrive at Mercury in 2025. This mission promises to provide even more detailed information about Mercury's surface, including its chemical composition and geological history. From its unexpectedly strong magnetic field to the presence of water ice, Mercury continues to surprise us. But what we're about to explore next will really make you do a double take. How does a planet so close to the sun manage to have a year shorter than its day? A year shorter than a day. When we think about planets, we usually imagine them spinning on their axis once a day and orbiting the Sun over the course of a year. But Mercury breaks this mold in a fascinating way. On this small, sun-scorched world, a year is actually shorter than a day. Let's break this down. Mercury takes just 88 Earth days to complete one orbit around the Sun. This rapid journey makes a Mercurian year much shorter than ours. But here's where it gets really interesting. A single day on Mercury, that is, one full rotation on its axis, takes a whopping 176 Earth days. This means that on Mercury, a year is only half as long as a day. This unusual situation creates some truly bizarre effects. If you were standing on Mercury's surface, you'd see the sun rise, then gradually grow larger in the sky as it slowly moves across the heavens. At some point, the sun would appear to stop, then move backwards for a while before resuming its original direction. This strange dance happens because Mercury's rotation can't keep up with its speedy orbit. But why does Mercury rotate so slowly? Scientists believe it's due to something called tidal locking. Over billions of years, the sun's gravitational pull has slowed Mercury's rotation. However, unlike our moon, which is completely tidally locked to Earth, Mercury is in what's called a 2 spin-orbit resonance. This means it rotates 3 times for every 2 orbits around the sun. The effects of this unusual day-night cycle on Mercury's surface are extreme. The side facing the sun bakes under intense heat for months at a time, while the night side remains in frigid darkness for an equally long period. This leads to some of the most extreme temperature variations in the solar system. Speaking of Mercury's atmosphere, or lack thereof, it's worth noting that what little atmosphere Mercury does have is called an exosphere. This incredibly thin layer of gases is constantly being lost to space and replenished by various processes. The solar wind, radioactive decay, and even micrometeorite impacts all contribute to maintaining Mercury's tenuous exosphere. Recent observations have revealed some surprising components in Mercury's exosphere. In 2020, researchers using the Messenger spacecraft data discovered that Mercury's exosphere contains more water vapor than previously thought. This water vapor is believed to be created when hydrogen from the solar wind combines with oxygen in Mercury's surface rocks. Another fascinating aspect of Mercury's short year and long day is how it affects the planet's magnetic field. Despite its small size and slow rotation, Mercury has a global magnetic field which surprised scientists when it was first discovered. Recent studies suggest that Mercury's magnetic field is generated by a unique dynamo effect in its liquid metal core, driven by the planet's peculiar orbital and rotational characteristics. This magnetic field, while much weaker than Earth's, plays a crucial role in protecting Mercury's surface from the harsh solar wind. Without it, the solar wind would strip away what little atmosphere Mercury has even faster. The combination of Mercury's rapid orbit and slow rotation also leads to some interesting possibilities for observation. There are specific points on Mercury's surface, called hot poles, where the sun appears to stand still in the sky at certain times. These hot poles experience the most extreme heat on the planet. On the flip side, there are areas near Mercury's poles that never see sunlight at all. These permanently shadowed regions are where scientists have found evidence of water ice. But how does ice survive on a planet so close to the sun? It's all thanks to Mercury's unique orbit and rotation. The permanently shadowed craters near Mercury's poles never receive direct sunlight, keeping them incredibly cold even as nearby areas bake in the sun's heat. This discovery has led scientists to wonder, could there be other volatile substances like organic compounds preserved in these cold traps? Mercury's short year and long day also affect how we study the planet. Because Mercury orbits the sun so quickly, it's challenging for spacecraft to reach it. They need to use complex maneuvers, including multiple flybys of Venus and Mercury itself, to slow down enough to enter orbit around the planet. The Bepi-Colombo mission, currently on its way to Mercury, will use these gravitational assists to gradually adjust its speed and trajectory. Launched in 2018, the spacecraft won't enter orbit around Mercury until 2025, after completing 9 planetary flybys. Once in orbit, Bepi-Colombo will face another challenge related to Mercury's unusual day-night cycle. The spacecraft will need to carefully manage its exposure to the intense heat on Mercury's day side, while also maintaining power during the long, cold nights. This delicate balance is crucial for the mission's success and highlights the extreme conditions created by Mercury's unique rotation and orbit. Recent computer simulations have provided new insights into how Mercury ended up with its current rotation rate. These models suggest that Mercury may have once rotated much faster, but was slowed down by the combined effects of the Sun's gravity and impacts from large asteroids or comets. This research helps us understand not just Mercury's history, but also how other planets in the solar system may have evolved. As we continue to study Mercury, new questions arise. How does the planet's core remain partially liquid, despite the long nights and extreme cold? What role does Mercury's unusual orbit play in shaping its geology? These questions remind us that even in our own solar system, there are still many mysteries to uncover. Mercury's unique characteristics challenge our understanding of how planets form and evolve, pushing us to expand our theories and explore new possibilities. So, what other crazy secrets might Mercury be hiding beneath its cratered surface? A small planet with too many intense secrets. Mercury, the smallest planet in our solar system, packs a surprising number of mysteries into its tiny frame. Despite its size, Mercury continues to baffle scientists with its unique characteristics and unexpected features. One of the most intriguing secrets of Mercury is its unusually large core. Dr. Nancy Chabot, a planetary scientist at the Johns Hopkins Applied Physics Laboratory, led a study that revealed Mercury's core makes up about 85% of the planet's volume. This is significantly larger than Earth's core, which only accounts for about 15% of our planet's volume. But why does Mercury have such a massive core? One theory suggests that Mercury may have once been a much larger planet that lost most of its outer layers in a massive collision early in the solar system's history. This idea, known as the hit-and-run scenario, was proposed by Dr. Eric Asfaug from the University of Arizona. According to this theory, a large planetesimal might have struck Mercury, stripping away much of its mantle and crust, leaving behind the iron-rich core we see today. Another intense secret of Mercury is its unexpected magnetic field. Unlike Venus and Mars, which have no global magnetic fields, Mercury generates a magnetic field about 1% as strong as Earth's. This discovery, made by NASA's Messenger mission, puzzled scientists because they didn't expect such a small, slowly rotating planet that appear to be volcanic vents. These features, known as hollows, suggest that Mercury may still be geologically active today. One of the most puzzling features of Mercury is its chaotic terrain, a vast area of jumbled hills and valleys near the planet's south pole. This region, first observed by the Mariner 10 mission in the 1970s, covers an area about the size of Texas. Dr. Thomas Waters from the Smithsonian Institution has proposed that this terrain might have been formed by massive earthquakes caused by the tidal forces of the Sun as Mercury's orbit evolved. Recent studies have also revealed surprising details about Mercury's composition. Dr. Amir Khan from the University of Zurich used data from the Messenger mission to study Mercury's internal structure. His team found that Mercury's core is likely composed of a liquid outer layer and a solid inner core similar to Earth's. However, Mercury's inner core is proportionally much larger than Earth's, which could explain some of the planet's unique magnetic properties. These intense secrets of Mercury challenge our understanding of planetary formation and evolution. They remind us that even in our own cosmic backyard, there are still many mysteries to solve. As we look forward to future missions and discoveries, we can't help but wonder, what other surprises might be hiding beneath Mercury's cratered surface? Mercury's hidden depths. Recent discoveries and ongoing missions are revealing that Mercury's subsurface holds secrets just as fascinating as its visible features. One of the most interesting aspects of Mercury's hidden depths is its core structure. Unlike Earth, which has a solid inner core surrounded by a liquid outer core, Mercury's core is mostly liquid with a solid inner portion. This unusual core composition was confirmed by NASA's Messenger mission, which used subtle variations in Mercury's gravitational field to map its internal structure. The solid inner core of Mercury is estimated to be about 1,260 miles, or 2,000 kilometers wide, making up nearly half of Mercury's entire core. This is proportionally much larger than Earth's inner core, which only accounts for about 20% of our planet's core volume. The size and state of Mercury's core play a crucial role in generating its magnetic field, which is much weaker than Earth's, but still surprisingly strong for such a small planet. Beneath Mercury's crust lies a mantle that's thinner than previously thought. Recent studies suggest that Mercury's mantle might be only about 260 miles, or 420 kilometers thick, compared to Earth's mantle, which is about 1,800 miles, or 2,900 kilometers thick. This thin mantle has implications for Mercury's geological activity and heat distribution. One of the most exciting discoveries about Mercury's subsurface came in 2012, when Messenger detected evidence of ancient volcanic activity. The spacecraft found unusual shallow depressions called hollows that seem to have formed when volatile elements sublimated from the surface. These hollows suggest that Mercury's interior once contained more volatile elements than scientists previously believed. In 2020, researchers using data from Messenger made another groundbreaking discovery about Mercury's subsurface. They found evidence of a vast underground reservoir of magma that existed in Mercury's distant past. This ancient magma ocean likely played a crucial role in shaping Mercury's surface and internal structure. The presence of this ancient magma ocean could explain some of Mercury's unique surface features, such as the vast smooth plains that cover much of its northern hemisphere. These plains, known as the Northern Volcanic Plains, are thought to be the result of massive lava flows that occurred early in Mercury's history. But perhaps the most jaw-dropping discovery about Mercury's subsurface came in 2022. Researchers analyzing Messenger data found evidence of nitrogen trapped beneath Mercury's surface. This nitrogen could be the remnant of an ancient atmosphere that was driven underground by the intense heat and solar radiation bombarding the planet. The presence of subsurface nitrogen raises intriguing questions about Mercury's past. Could the planet have once had a more substantial atmosphere? If so, what implications might this have for its early climate and potential habitability? Another fascinating aspect of Mercury's hidden depths metal surrounding a solid inner core. Another weird aspect of Mercury's hidden depths is the possibility of subsurface faults and fractures that could provide pathways for heat, and potentially even fluids to move through the planet's crust. While Mercury's surface is bone dry today, some scientists speculate that there might be pockets of liquid water deep beneath the surface, kept liquid by residual heat from the planet's core. The idea of subsurface water on Mercury might seem far-fetched, but similar phenomena have been observed on other seemingly inhospitable worlds in our solar system. For instance, Jupiter's moon Europa and Saturn's moon Enceladus both have subsurface oceans beneath their icy crusts. While Mercury's environment is very different, the possibility of subsurface water can't be entirely ruled out. As we continue to explore Mercury's hidden depths, new questions arise. How has Mercury's internal structure evolved over time? Could there be other volatile elements or compounds trapped beneath its surface? And perhaps most intriguingly, what might Mercury's subsurface tell us about the early history of our solar system and the processes that shaped the inner planets? These questions highlight the importance of continued exploration of Mercury. Each new discovery about its hidden depths not only enhances our understanding of this fascinating world, but also provides valuable insights into planetary formation and evolution throughout the solar system. As we look forward to future missions and discoveries, one thing is clear. Mercury, despite its small size and proximity to the Sun, still has many secrets to reveal. Its hidden depths hold clues to its past and potentially to the history of our entire solar system. What a journey, right? Share your thoughts about what we could find on Mercury in the near future. Could it be precious stones, or possibly even extraterrestrial life? If you enjoyed this video, make sure to smash that like button and subscribe to the channel so you never miss out on any updates. Thanks for watching, and we'll see you in the next one.